Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to go through an example of how to find area bound between two curves. So what we're going to do here is we're going to look at the curve y equals minus x squared plus 4, the curve y equals minus x minus 3, and try to find the area bound between them. So you always want to start these with a picture. I've already drawn the axis in here, so minus x squared plus 4 is a parabola, opens down, goes through the point 0, 4. So this thing's a parabola. It's looking something like this. Keeps going forever, basically. Negative x minus 3 is a line. Intercept at negative 3. 1, 2, 3. It's down here somewhere. With a negative slope. So slope being minus 1. I'll actually set that to minus 45. Give us a pretty good look at it. Whoops. All right. Now, I'm going to go back and modify my parabola a little bit. Whoops. Darn it, I did it again. Well, anyway, everybody knows what I mean. All right, so first thing I realize is that these things cross twice. We're going to need to find the where they intersect. So the key to the intersection is that they have the same x or same y coordinates. I'm going to use the fact that they have the same y coordinates, which means we can take minus x minus 3 and set it equal to minus x squared plus 4. Now this may or may not factor. I'll go ahead and give it a try. What I usually do is I usually give it to about 1003 to factor. If I can't factor it by 1003, I usually just move to the quadratic formula, but let's see what happens. So I'm going to move this to the left. That's going to be x squared, and then minus x, and then negative 3 minus 4 more is going to be minus 7 equals 0. I'm going to double check that, make sure. Plus x squared minus x, yep, minus 7. So factors of 7, 7, and 1. I see no prayer of this having integer solutions. So go right to the quadratic formula. So x is going to be the opposite of b, plus or minus the square root of b squared, that's going to be a 1, minus 4, a is 1, c is negative 7, I'm going to put a 7 here and the minus sign, I'm just going to move over there and do that, and then that's over twice a. I'm going to take a moment here and pause this while my helpers here look for a solution to this. Alright folks, I'm back here. So we've got solutions to the previous quadratic equation here. Negative 2.19 for our lower bound here, positive 3.19 for our upper bound. Hopefully they're right. Now, if we want to find an area, the first thing we have to do is draw an area element. Very important. When you're taking a calculus class with me, if you don't do this step, I don't even grade the rest of it. So what I'm going to do here is I'm going to draw my differential element. I guess it doesn't have to be perfect. In a nice vertical rectangle, anywhere along here would be a good element to draw. It doesn't really matter where inside of here we draw our element. I usually draw mine so that it's got a measurable thickness that I can see, just so that I can recognize it as a rectangle. Now, what we label this distance as, whether it's a dx or a delta x, this kind of depends on how you're going to attack the problem. If you're going to use a computer and do a numerical solution with maybe 10 rectangles, you would label it as a delta x, a finite measurable x. But if you're thinking about using an integral process, you're basically doing an infinite number of rectangles, in which case the width is a dx. It's infinitely small. In either case, this rectangle needs to be labeled. The width needs to be labeled. In order to calculate the area of that rectangle, we're going to need its length, so I'm going to label that as well. All right, so the length of that rectangle is going to be, now both curves are involved. You always do, when you're bound between curves and you want a length, you always do upper curve minus lower curve. So that's going to be equal to minus x squared plus 4 minus, I'm going to put that in parentheses, that's the upper curve minus the lower curve, which is minus x minus 3. So the length of that rectangle, let's see, we can rewrite this a little bit, is equal to minus x squared, and then plus x, and then 4 minus a minus 3 is plus 7. Okay. This stuff needs to be labeled because the equations for the area are based on it. All right, so now, next step, I'm going to write myself an equation for the area of that rectangle. That area is going to be length times width, so minus x squared plus x plus 7 times the width dx. There's my area. Total area we get by adding these all up. That's what the integral does for us. That's actually an S, stands for infinite sum. Minus x squared plus x plus 7 dx, running x from, let's see, minus 2.19 to positive 3.19. Alright, I'm going to go ahead and make myself a little more room here. I don't really, and we'll take this and we'll move it. Alright, so now we're just going to work this term by term, and this can be, the integral symbol distributes across this just like you think it would. So the integral of minus x squared dx, I'm going to write this up top here, is going to be minus x to the third over 3. Integral of x dx is plus x squared over 2. And the integral of 7 dx is plus 7x. And then our limits, this is evaluated from minus 2.19 to positive 3.19. Now it's just a matter of putting in values. So we're going to have minus 3.19 cubed over 3 plus 3.19 squared over 2 plus 7 times 3.19. That's the top limit. I need to make myself some room here to do the bottom limits. So I'm going to take this stuff and shrink it down a little bit and move it down a little lower. Okay. All right. Minus, I'm going to come down here and put the bottom limits. Now we're going to put in minus 2.19. So minus a minus 2.19 cubed over 3. Lots of minuses floating around. This one is coming from the evaluation of the limit. This one is coming from the antiderivative term. This one is because the bottom limit is negative. Right. Plus a negative 2.19 squared over 2 plus 7 times a negative 2.19 equals. So I'm going to take a moment and pause this so the video doesn't get too long while my helpers here calculate a value for me. Alright folks, I'm back here, and after a little bit of debating and a couple tries here, we're getting around, looks like about 26 points something. 26 is good enough. This is an area problem, so let's call it 26 square units. So, purpose of this video is to demonstrate how to find the area bound between two curves using integration. Have a great day.